All right, guys, so this is nomenclature. It's basically just figuring out how to name compounds. As we've discussed in the past, remember that the first column elements have a +1, second column is +2. And then, yes, I do remember us talking about this column right here being +3. But I just want you to know boron right here is not really +3 because it's technically a nonmetal. So that's why here I'm just going to leave it blank. And that's why you should just know that these two, aluminum and gallium, are definitely +3. And then everything else below here is really just, we have to figure out the rest of these. And same thing with all of these down here. Since these are metals, these should not have a minus charge. And so that's why really the charges stop at that staircase line for any of those minus charges. But pretty much for all of the other things that I have written out here, this is the charge of all of them. And you should have this memorized, including the fact that zinc is a 2+ charge, cadmium is a 2+ charge, and silver is a 1+ charge when they lose electrons. So please make sure you have all of this memorized. This is essential for naming any of the chemical compounds. Okay, so you're just going to hear me say a couple words, which is very important. The first thing is if I say binary compound, it just means any compound made up of two elements. So a good example of that would be kind of like NaCl. It is made up with sodium and chlorine. So that would be a binary compound, whereas something like H2SO4, this is not binary because there are 3 elements or more, okay? But similarly speaking, MgCl2, this is also considered binary as well because this has magnesium and chlorine. It is still 2 types of elements, even though there are technically 3 elements in total in that compound. Okay, so it doesn't really have to do with the number that's attached to them. It really just has to do with the types of elements. And then another thing to keep in mind is knowing that 2 non-metal elements put together, that non-metal compound is called a covalent compound, whereas if it's made up of a metal and a non-metal, that is called an ionic. So if you know from earlier that same example, NaCl, sodium is a metal, chlorine is a non-metal, and so that's how I know that this is an ionic compound. Whereas if I gave you something like CO2, this is also binary because it's made up of 2 elements, carbon and oxygen. And carbon we know as a nonmetal. And oxygen we also know as nonmetal. And so since it's made up of only nonmetals, we know that this is a covalent compound. Okay? All right, so just going in a little more detail about ionic compounds. Remember, an ionic compound is something that's made up of a metal and a nonmetal from the earlier slide. So remember, metals are called cations when they turn into ions, and nonmetals will turn into negative anions. Remember, a cation is something with a positive charge, and an anion is something with a negative charge. So that being said, all types of ionic compounds, whether it's binary or if there are more than 2 elements, regardless, all types of ionic compounds should have 2 positives and negative 2 charges present. Okay, and those charges are what's going to balance to create the compound. Okay, and those 2 charges, so an ion can be either a monatomic ion. So as you know, the word mono means 1. So if there's only 1 atom, so like sodium ion right here, this is considered a monatomic ion. Or that ion that the ionic compounds are made of, it could be a polyatomic ion. And as you know, poly means many. So if it's made up of more than 1 atom, so many atom ion, kind of like the polyatomic ions you had to memorize. This would be an example of a polyatomic ion because it's made up of multiple atoms, nitrogen and oxygen, and it's a -1 charge. It's an ion. Okay. All right, so here is how you write a binary ionic compound. Really super simple. If you wanted to read through this, you totally can stop now and then read through it, but I think it's always easier if I just show you. So if you are writing a binary ionic formula, and let's say the ionic compound that's being formed is between calcium and chlorine. So all you have to do is you have to just write out the ion form of those 2 things. So I'm going to go ahead and write calcium, and calcium is a 2+ charge based on the fact that it's in the second column of the periodic table. And chlorine is a -1 charge because it's on the 7th column of the ones that we talked about earlier. So this is something that you should already know. And when we do this, we just have to put those elements together to where they will balance. So ionic compounds are all about balancing the charges and making that they're neutral. So if I look at this here, calcium is a 2+ charge, and to balance the charge for the negative, if I only had 1 calcium and 1 chlorine, that would be a total of a 2+ -1, which is an overall +1 charge, which is not neutral. It's a positive charge. So we actually don't want just one of each. So you really have to just think, what can we do to balance those charges together? And in my head, I know that if I double the amount of chlorines, then I will have a -2 charge overall. And so to say that we need twice as many chlorines, we will actually put a 2 in the subscript on the bottom of the chlorine. So this is letting me know that it's 1 calcium with a 2+ charge, and it's 2 chlorines with a -1 charge, so that's 2 times -1. And if I combine those two, a 2 positive and a 2 minus, this will cancel each other out and become a neutral 0 charge. And so that's how I know it's correct. And so that's why the correct formula for a compound made up of calcium and chlorine is going to be just like this: 1 calcium and 2 chlorines. Okay, so if I did the next one, so looking at magnesium and oxygen. So if I look at magnesium, it's in the 2nd column, so it's a 2+ charge. Oxygen is a 2- charge. And look at how this one already has a +2 and -2. And so that's why in this scenario, I don't have to try and figure out how many of each. It's already balanced. And so my completed formula would just be 1 magnesium and 1 oxygen together like this. But if I did barium and nitrogen, so looking at barium is a 2+ charge. Nitrogen is a 3- charge. So this is where you have to kind of think, how can I make them be the same charge so that they'll cancel, right? I would want the same value, so the least common multiple, you know, that math term. So if I thought about it, what is a common number between 2 and 3? And in my head, I know the common number between 2 and 3 is 6. So I think to myself, how many times do I multiply barium to be 6? And I know if I have 3 times as many bariums, that would be a total of +6 charge. And nitrogen to become a 6, I know if I have 2 nitrogens, that'll be a total of -6. And so I'm going to combine those two, and when those 2 barium and nitrogens come together, it will actually form Ba3N2 as the binary ionic compound. Okay. And so what does all this mean? Why does it have a specific number that it needs to balance the charges with? Remember, a long time ago, we learned about how atoms will tend to give away their electrons or gain electrons to become an octet. So if I drew you calcium, what calcium has is, let's say, okay, it has a lot of electrons in its inner core, but on the very outer, calcium has 2 valence electrons. And chlorine has many in the center, has 7 on the outer, and so one of these electrons is going to fill the 8th spot that the chlorine needs, and it needs another chlorine to take that other one. Okay, so do you see how here calcium had an electron that it's going to give away to chlorine, but it needs another chlorine to take that other electron? And so now do you see how it's 1 calcium needs 2 chlorines to fully give away his electrons, and those chlorines are kind of married, if you'd like to think, married to that calcium because there's 2 of them that took each electron. Okay, so that's what all of these subscripts means. It's a ratio of how many bariums to nitrogens, magnesiums to oxygens do you need to give away and accept those electrons. So go ahead and try and do the rest of these on your own. So if you want to pause right now to try it on your own, I'm going to go ahead and upload the answers in about 10 seconds. So, all right, welcome back. Here are the answers. Hopefully you got the same things I did. And remember, look at how all of the cations that I have listed here on this side, these are the positive charges and the anions are the negative charges. And you're pretty much just trying to combine them to balance to become a neutral charge in the formula. Okay, so let's try going backwards now that we understand how to go from combining elements to writing the formula. How do we read the formula to its correct nomenclature, to its correct name? And so all you have to remember is that monatomic ions that are cations, you just read the element like it says. So Na, you know from the periodic table, is just sodium. So if it's positive cations, you just read it like how it is. But monatomic anions, this is slightly different. Whatever the name of the element is, so you know of this element, if it wasn't an ion, you would read it as chlorine. And what you're going to do is you're going to take away the ending and you're going to change the ending to become an IDE ending. So instead of chlorine, we would change the ending to chloride. So if I gave you this example here, you just have to look and see what part of this compound, and we know it's a compound because it has multiple elements involved. In this compound, what is the positive cation and what is the negative anion? So I'm going to go ahead and see that potassium, this is our positive 1 cation, whereas the chlorine, this would be our negative 1 anion. So remember, the way we read positive cations is we just read it like how it normally is from the periodic table. That would be potassium. And then the second word would be chlorine if it was an element by itself, but because it is an ion in a part of a ionic compound, the way we change the name for that would be chloride. And yes, it is 2 separate words. So looking at here, I see that the first magnesium, so we ignore the 3. Okay, remember these subscripts we just ignore because they're just based on the number of that element. So ignore these 3s and the 2s, okay? We're really just concerned with what is the positive ion and what is the negative ion. So I see magnesium would be our positive cation because magnesium from the periodic table we know is a positive 2 charge. Whereas phosphorus, from the periodic table, I know that as a negative 3 charge. And so here I have gone ahead and looked at the cation and anion. And so I can go ahead and say the first part, the positive cation, we read like normal, so that's magnesium. And then the second element, the second ion, is the negative anion. So it would have been normally phosphorus, but remember we changed the ending. So phosphorus, we just take the first syllable, so we just say phosphide. Okay, so you leave out the rest of the word, just take the first syllable and you change the ending to ide. So let me go ahead and do the rest of these. So if you want to pause now, I'm going to upload this answers in just a few seconds. Okay, so here are the names of all of these, and of course with any time you write out the full name, capitalization does not matter.